Hello, my dear students. Welcome to the class. Today I'm here to discuss another important topic in our Math Simplified series. So today the topic is integration by partial fractions. This again comes under method of integration. We have already done by parts. So if you have not watched that session, if you are yet to learn from there, go and check it out. Okay, so in that session I talked about different forms of integration by parts and solved some questions as well. Great. So why we need this chapter, why we need this concept, okay, and how it is important. So why we need it, we'll come to that later. Let's understand why it is important. So almost every year in your second PUC, one question is guaranteed in 3 marker. Okay, means one question of 3 marks will come in your second PUC boards. Clear? One question will also, chances of one question coming in KCET also is very high. So if you look at last 5 years paper, 3 to 4 times you'll find the question in KCET as well. That's very good, probability that you should go and prepare this topic. Okay, and again, this is not very difficult if you understand the forms clearly, when to apply, what form to apply. So I'll discuss different forms involved over here. That is as per our syllabus. Again, some questions on those forms. Clear? So what are we going to do over here? We'll learn concept and problems of integration by partial fractions. Let's start this session then. And if you think this will help you in your preparation, do not forget to hit the like button and share this session, share this class with all of your friends who are in second PUC or preparing for KCET. Certainly, whatever we are doing over here on our channel, Diksha Karnataka, will help them prepare in the best way for all the subjects that is going on our platform. Let's start. So what is a partial fraction? Of course, so this is again, this falls under the category of solving questions of proper fraction form. Okay, means when degree of numerator is less than degree of denominator. For those kind of question, we break it down. What we do, break it down? We break down the denominator, okay, in 2 different factors. So you have already given here factors x minus 1 and x plus 2. Sometime in the question, they might not give that to you. You might have to perform the factorization. You might have to perform the factorization, and from there you put the factors over here and then integrate, right? You can integrate like this, no problem here. What is the property? So basically, if you have to integrate sum of 2 functions, you can integrate them individually and then also take sum, right? That's the property of integration over the sum. So you can integrate them individually. And how can you integrate this? So if you did not break it down in the partial fractions, then it'll be difficult integration, isn't it? How do you integrate this? Very difficult to do because there's no direct formula for this. But for this part, there is a formula you can apply, a ln a. Okay, it becomes a ln of x minus 1, not a, pardon me, a log of x minus 1. And likewise for this partial fraction as well. I hope this makes sense. Okay, let's move on then. So as I mentioned, there are 2 types of fractions basically in the rational function part. So number 1 will be the proper fraction where the degree of px. What is px, sir? So if I write the rational function bacha as px by qx, then px is the numerator. If that is less than degree of denominator, which is qx, that comes under the category of proper fraction, right? That you can solve, of course, directly in the approach we learned right now. But in the case of improper fraction, you have to do the long division first. Means you have to do this division first. X square minus 1, x cube plus 1. Okay, you'll get a quotient plus that remainder by this particular value, right? That's how you write it. You're going to write it as quotient plus whatever is the remainder by this value x square minus 1. And this will be basically your integration. For partial fraction, this will be simple integration, okay, of whatever function of polynomial nature is coming. You can integrate that right now. You can integrate that. Makes sense? Okay, sir. So you have to do the long division and then reduce to the quotient plus proper fraction, and then you can perform this integration. That is the second case, right? Now the cases we have over here means there are different forms of partial fraction problem comes. So we'll look at all of them one by one. One where, sir, denominator is in the product like this. So this qx represents what? Denominator, right? When denominator is multiplied like this, x minus a, x minus b, x minus c, means all 3 or more distinct factors are given in the denominator. And numerator is, of course, following the case of, what is this? This must be a proper fraction. proper fraction. So if we are applied the partial fraction condition, understand we can apply only to the proper fraction. Okay, for the improper we have to divide first and then take the proper part and then apply to that content. Okay, so once you have that, so if you have 3, 4, 5 same number of constants, you have to assume like a, b, c. If you had x minus d also, you'll do that plus, one second. Achha, one more thing, there's no, like in this question it is looking like this, sir, a upon minus a, b upon minus b. It is not the case. It can be some other number also. It can be 1, 5, whatever it is, and this can be a different number. So do not ever think that, sir, this is d, this is also d. Okay, I know it's a silly question, but if somebody is thinking this way, let's get that sorted. Clear? Okay, so how to find ABC? Multiply both sides with qx to clear denominators. Basically, what you're going to do? Multiply both sides by, basically you have to take the LCM over here. How do you add fractions? Same way. How do you add fractions? Same way. Then start in this, you have to compare the numerator only. Compare the numerator only. Okay, once you compare the numerator, you will have to put x as a, x as b, x as c to eliminate two other variables, keeping one intact and finding the value. That's why I said one at a time. Each substitution kills all the terms except one and solve that to get that unknown variable. What is capital A equals to what is capital B, what is capital C, what is capital D equals to. Does it make sense or not? Yeah, this is the case 1 where we have distinct linear factors in the denominator of proper fraction form. Okay, let's move on. Next, which is case 2. Sometimes in the question they might have given you, repeated factors. Means they can give you x minus a into x minus a. What is this is going to be? X minus a square, right? So we'll have repeated linear factors sometime. In those cases, okay, you'll write once x minus a with the constant a, and next time another constant you have to write. Means basically for two factors you have to write what? Two different constants, right? But will you write x minus a over here? No. If you do that, it'll become same, right? So let x minus a the whole square, the same repeated factor, and then the other linear as it is. Okay, so basically to give you a clue, based upon what is the nature of denominators, polynomials degree. So this over here, what is the degree now? X will be over here, square, here it is going to be x, it becomes 3. Degree is 3. So you'll have 3 unknowns. You'll have 3 unknowns. Okay, look at the previous question. It was of the degree x into x into x. So 3. You have A, B, C, 3 unknowns. If I remove the D part, which is not relevant, I just explained you using the concept. Yeah. So you'll have how many? Again, 3 only. Let's move on then. Clear? So this is one question that we can solve right now based upon the case 2. What happens? Achha, this is the one, right? Yeah. Let's do the question. Work example. So if the question is given to us, integration of x plus 1 upon x minus 1 the whole square times of x plus 2 times of x plus 2. Understand, is this proper or not? It is proper, sir. We have a degree of numerator as 1 and degree of denominator as 3. Okay. So let's expand it. Write first one as a upon just x minus 1. Okay. And of course, we'll have to write the integration variable as well, dx plus integrate one more time, b upon whatever is over here, the repeated linear factor, write one more time. So we'll have to write this as x minus 1 the whole square. Again, we'll have dx bacha and plus integration of the last one. What is that? C. You'll have over here x plus 2, again dx. Okay. So how do you solve this from here? If you, this is just, breaking down in the basically what do you call partial fraction form. So if you just look at the partial fraction form, how do you solve this step? So if I just write, if I forget about integration for now and solve it for partial fraction, check this out. What will be my LCM? X minus 1 whole square and x plus 2, right? That's my LCM now, correct? Product of these two, if you take LCM, right, this will be the value. So x minus 1 the whole square times x plus 2. Correct? Now, if you divide this to the whole of this, what will happen? You'll have x minus 1 times x plus 2 left, because here we have whole square. So you'll write this as a times of x minus 1 into x plus 2. What about with b? With b, if you divide, this whole thing will be cancelled. Only x plus 2 is left. So x plus 2. What about with c? Divide with this, you'll have the whole square part left. So you'll write c times of x minus 1 the whole square. Okay. Now write the LHS part also. As I mentioned, we write without the integration. Okay. So x plus 1 upon x minus 1 the whole square and x plus 2. And x plus 2. Okay. This is clear, guys. Okay. Now, since they have the same denominator, you can compare what? Only numerator, guys. So can you see closely? Same thing I've written over here. X plus 1 equals to a times of x minus 1, x plus 2, b times of x plus 2, c times of x minus 1 the whole square. Clear? Okay. Now, start putting x as 1. X as 1. When you put x as 1, what will happen? This will become 1 plus 1, that is 2. This will become 0 because 1 minus 1 is 0. This will also become 1 minus 1, so 0. You'll have only b times of 1 plus 2, which is 3. So you'll have 2 equal to 3b. That gives me b equal to 2 by 3. B equals to 2 by 3. So out of the 3 unknowns, b value is now known as 2 by 3. Moving on, put x equals to minus 2 now. Okay. When you put minus 2, this will be 0, this will be 0. Because here minus 2 plus 2 is 0, here also 0. Here you'll have minus 2 plus 1, that becomes minus 1. Over here you'll have minus 2 minus 1, that is going to be minus 3. Squared up, it will become 9. So you'll have 9c. Divide on that side, it becomes c is minus 1 by 9. This is going to be minus 1 by 9. Can you see? Minus 1 by 9 log of x plus 2. Right? Same way, if you compare the coefficient of x square. Where is the coefficient of x square, sir? So we have over here. Can you see there will be a coefficient of x square over here, which is going to be a. What about this, sir? You'll have c. So if you simplify this version, you will have expansion of this as x square plus 1 minus 2x. So from this term, let's see, c times of x square plus 1 minus 2x. Now guys, if I ask you all, Bacha, tell me what is the coefficient of x square from here? You will say c. Again, expand over here also, x into x is x square. What is the coefficient of x square in this term? A. So from the right hand side, you can see the coefficient of x square is a plus c. This is a and this is c. So a plus c. Look at the left hand side, x plus 1. What is the coefficient? Nothing is there, sir. There is no x square. It means it must be 0. Because if I write over here as 0 x square plus this, it means what? The same thing, 0 only. So I've taken a plus c as 0. Since c is minus 1 by 9, a becomes 1 by 9. Again, you can do your own calculation as well. Try once and let me know. Okay. Now, so understand, this is a straight away log function because this is going to be 1 by 9. This will be what? Minus 1 by 9. Again, log function. What about this? This is a polynomial function. This is a polynomial function. So don't treat this as log because the power is 2 over here. You see, this is not log. This is actually the power rule. This will become what? X minus 2 power minus 2 integration. Apply that condition over there. So you're going to get what? Minus 2 by 3, 1 upon x minus 1. Okay, that's the actual answer. I hope there's no doubt regarding any of the steps. Clear? Okay, case 3. Now, there can be some questions. So case 1 was straight away when you have linear factors given. Case 2 was when you have repeated linear factors, means squares, cubes, like that is there. Case 3 was when you have irreducible, means you cannot factorize it anymore. This quadratic is there, but it is not able, you're not able to factorize this case. Then how would you solve that? So in that case, the constant is always the linear form. Okay, whenever you have irreducible quadratic factor, means you cannot factorize it any further, then the numerator will be always a linear, linear condition. Okay, you have to take that. Okay, an irreducible quadratic can't be factorized in two real linear term, needs a linear numerator, which is why bx plus c. But remember, clear understanding is same only. Degree of denominator is what, beta? Check here, x square x. Qx is what? Denominator. Degree of denominator is what? Still x square into x, 3 only. How many constants are there? A, B, C. right? Based upon degree of denominator, you'll have those many constants, right? So this is going to be basically unaltered. Same concept will remain over there as well. Okay. And how do we know whether it is irreducible? Whenever you have the discriminant value negative, means no real roots. You cannot have a split of linear factors. You can, one way to check that is there. Example also given to you, 1 upon x times of x square plus 4. How would you write this as? If I just write the fractional part, 1 upon x times of x square plus 4, you cannot factorize it any further. So you'll have a upon x plus bx plus c upon x square plus 4. Please simplify this. You'll have x times of x square plus 4. Over here you'll have a times of x square plus 4, and over here you'll have plus x times of bx plus c. Bx plus c. Simplify this. You'll have a x square plus 4a, and you'll have plus bx square plus cx upon this x times of x square plus 4. Please compare the coefficient, okay, because you have the coefficient as 1 only. If you look at this side, it is only the constant 1. Compare, guys, and check the answer. Okay, check the answer. If you want, please check the answer. If you just compare the constant term, you'll have 4a equals to 1. So a value is what? Excuse me, 4a equals to, my bad, 4a equals to, if you take 1, you'll have a value as 1 by 4. Okay, and for x square, you're going to compare what? The coefficient. You'll have a plus b over here. You'll have a plus b, that is 0. So you'll have a plus b as 0, because look at the left hand side, there is no x square term. And over here we have two x square term, a and b both. So you'll have b value as minus a. That'll be what? Minus 1 by 4. And check here, there is no x coefficient. There is no x term over here. Okay, so 1 represents what? This means 0x square plus 0x plus 1. So even c will be what? 0. You'll have c value as 0. Check. So c value must be 0, b is minus 1 by 4, a is this, and this is your integration final. This will be again polynomial. This will be your log function. Can you see? Yeah. So this is becoming log only. Okay. Because this is based upon substitution actually. Yeah, this will be based upon substitution. You can take x square plus 4 as x square plus 4 as what? T. So it will become 2x dx as dt, and one of the x is present over here, and that's why. You can try from there. Okay. This is coming as log because of substitution. Okay. Substitution of what? X square plus 4 as t. You can try that. Please try this method and let me know. If you want me to make a session only for substitution method also, let me know. I'll include that in one of the math simplified sessions. Okay. The quick reference to all the three cases: distinct linear, repeated linear, and irreducible quadratic. Forms are a by x minus 1 and b, and then you have a by same thing repeats, and over here you'll have linear form. Clear? All references are clear? Okay. Let's go and solve some questions now. Okay. So dx upon x square minus 9 is equal to what? How do you solve it? Again, let's just take the fraction, because if you look at this, the fraction is 1. Only 1 is there in the numerator. Excuse me. Something is wrong. Okay. X square minus 9. So it becomes 1 upon x minus 3 and x plus 3. Am I right? Yeah. So a upon x minus 3, x plus 3. Sorry. Excuse me, guys. My bad. This is wrong. Yes. Okay. Plus b upon x plus 3. Cross multiply a times of x plus 3 and b times of x minus 3, because we are doing the cross multiplication. This over there and this over here. We have x minus 3 and x plus 3. This side we have 1 upon the same two brackets. Same two brackets. Just compare the numerator. You'll have 1 equal to x plus 3 into a, and b will be x minus 3. Please cross check. Cross check. A times of x plus 3, b times of x minus 3. Am I right? Now put once x equals to minus 3. This will become 0. This whole thing will become 0. So you'll have, check this out, you'll have this as it is 1 only. This is 0, sir. You'll have b times of minus a is minus 6. So b becomes what, equal to minus 1 by 6. Now next you're going to put x as plus 3. This will be 0. And the question becomes 1 equal to 3 plus 3 into a. So a becomes equal to what? 1 by 6. A becomes equal to 1 by 6. Right? The question that you had was this, right? Integration of a. A will be 1 by 6, right? Check here. A upon x minus 3 is there, right? We'll have 1 by 6 into x minus 3. Correct. Minus 1 by 6 x plus 3. Correct now? B is with x plus 3 and b value is coming as minus 1 by 6. They're both integration, by the way. Please check. You'll have 1 by 6 is a common term. We can take it outside. This will become log of x minus 3 minus log of x plus 3 plus c, the constant. If you perform the quotient rule over here for logarithm, you'll have 1 by 6 outside log of, okay, there's the same thing, right? I've written ln, so let me just write this as log only. Okay, they are log only. Okay, so log of x minus 3 upon x plus 3 plus c, same as the answer. You can check over here as well. X minus 3 upon x plus 3, that's the option number A. This is the question, right? So I hope all the steps are clear. Correct? Starting from the branching into partial fractions, then converting it and finding the value of a and b, I've done over there, and then putting it back in the partial fractions and then doing the integration. And this is all, both of them are in the form of log. So we have the answer log in both the cases. Then the formula is log a minus b, log a minus log b, that becomes log of a by b. That's the result. Option came as option A. Have a look. Question number 2. Okay, so again, this is that repeated wala form, right? So how do you solve this one? How do you solve this one? Okay, let me just solve it over here. What is the space given over here? So we have x plus 3 upon x minus 1 the whole square. Am I right? Correct. Now write this as, you'll have write x, one of the factors, and then b, yeah, correct, we have that only, nothing else is there. Correct now? We have only one. Okay. So cross multiply now. So you'll end up with, if you multiply over here, you're going to end up with a times of x minus 1 plus nothing divided by x minus 1 the whole square, and this side we have x plus 3 x minus 1 the whole square. Since they are same in the denominator, we can compare they are directly numerator. So compare the numerators. Check. You'll have x plus 3 equals to a times of x minus 1 plus b. Put here x value as 1. Why? Because this will become 0. 1 minus 1 is 0. Put that over here, you're going to get 4 equals to b. So b value is coming as 4, because this is going to be 3 plus 1 is 4. This is simply b. Okay. All right. Let's compare the constant term now. Let's put x as 0. Because b we know now it is 4. This value is 4, right? So we'll write this again. Let x plus 3 equals to a times of x minus 1 plus 4. Because b is 4 now. Now put x value as 0. We'll get over here as 3 a into minus 1 plus 4. Okay. Now I'll move this term over here and this term over there. So it'll become plus a is equals to 4 minus 3. That is how much? 1. So a is coming as 1 and b is coming as 4. Right. So let's use that in the integration. So we have integration of 1 upon x minus 1 dx plus 4 times of integration of b is 4, right? 1 upon x minus 1 whole square, again with dx, right? So if you integrate, you'll have log over here, right? You'll have log over here, right? Correct, yeah. You'll have log of mod of x minus 1. I was just checking whether I made any mistake in the calculation. I have not. B is 4, A is 1. This is log. And what about this? This is polynomial function. You can write it like this also. X minus 1 power minus 2 dx. So you'll have log of x minus 1 plus 4 times of, check this out, you'll have x minus 1 minus 2 plus 1 by minus 2 plus 1 plus c. Formula is minus n, or basically n plus 1 upon n plus 1. N is minus 2, so n plus 1 will be minus 2 plus 1 divided by n plus 1 will be again minus 2 plus 1. Continue. You have the answer, log of mod of x minus 1. This value over here becomes, check carefully, this becomes minus 1. So you have minus 4, this is minus 1, and this will be 1 by x minus 1. 1 second, guys. Yeah. 1 by x minus 1 plus c. Log of x minus 1, 1 minus 1 by minus 4 times of, this is correct, right? Option A is the right answer. Check. Yeah. Log of x minus 1 minus 4 times of minus 4 times of 1 upon x minus 1 plus c. That's your answer, guys. This is your answer. Clear or not? Have a look. This is very important, okay, for all of you. Do prepare them well. All right. Now, so 2 questions I've solved, and this one will be your homework. So you have to give me answer. You have to give me answer where? In the comment section. Question number 3, what is the answer? So again, how do you solve it? X into x square plus 1. You cannot factorize it anymore. Okay. So this is the form given to you. X times of x square plus 1. Okay. Write it as a upon x plus bx plus c upon x square plus 1. Then you simply do the same process, find the result, okay, and leave me the answer in the comment section. Again, don't worry, I'll give you the answer, but in the notes. Where will you download the notes? AIU, all in one page is there, right? You'll click, you'll go and check in the description, you'll find all in one, you'll find the platform. Create login credentials, start getting all the PDF, all the notes over there only, okay? All in one is a free learning platform where you get lectures, where you get, notes, assignment questions, everything, doubt solving, all for free in our Vedantu learning platform, online learning platform. Is called as all in one, okay? So, okay, I'll give you answer. This is your homework. Join all in one. You'll get solution. Basically, you'll get the PDF. In the PDF of this particular session, I'll attach that particular questions answer, everything, all the lectures that you can see on our channel will be having the notes also provided over there itself. This is clear. This is clear. Now I have an important very important update for all of you, information for all of you regarding our ongoing offer for Independence Day. So Pariksha Veera batch, our official full year KCET batch, plus KCET plus second PUC batch is going on, right? We already started from 6th of July, but because of Independence Day, we are giving you all 50% off up till Sunday, which is 16th of August midnight. Okay, after that there will be no offer as such, and first few seats will be getting this particular this offer price of the batch. Okay, let me show you the same thing right now. Just give me 1 second. So if you check any of our sessions description, okay, for example, this is a lecture and you go and check this out, you're gonna find this is the link for your AIO, and this over here, register for free Pariksha Veera. This link, if you check, register for sorry, not free one, this is the paid batch of full year. So register for Pariksha Veera. If you click on that link, you will get this page open in front of you. Pariksha Veera KCET full year course. Okay, and yes, wish to ace the KCET 127, join the Pariksha Veera batch. The limited seats available and the offer is going on. The offer for the batch right now is at 50%. 2499. Go and check this particular batch right now and join as soon as possible. You'll get a lot of features in this. You're gonna get lectures. Okay, every day we have 2 lectures. First one starts at 4 p.m. But don't worry, all the information is provided in this website. You can go and check it out. The lectures, all the subjects will be being covered. Okay, the results that we produced, everything that you need to know, go and check it out. Check with your parents, and once it is done, try to take it as soon as possible. Okay, so this is clear, guys. This is regarding our Pariksha Veera batch, our full year. Okay, full year KCET plus second PUC batch. Okay, so that is all in this class today. I'll see you in the next session. Till then, of course, join this batch and take care. Keep working hard. All the best. See you in the next class.